This question talks about a balloon that is rising at a constant speed of 2 meters per second. Okay. The second half is a boy is cycling along a straight road at 5 meters per second. The balloon is 5 meters above the boy as he cycles underneath. How fast is the distance between the boy and the balloon increasing at t equals to 3? Before we start anything, we should start by sketching a diagram of this. We start by interpreting this thing as a diagram. So the first part that I pick out is the balloon is 15 meters above the boy as he cycles, meaning that from our zero or initial, there's already a distance, vertical distance of 15 meters per second between the balloon and the boy. The second part are these two, which is the constant speed of the balloon, which is given as distance over time. For the sake of this question, since the balloon is going up, we'll make this the vertical. Therefore, this will be dy dt equals 2 meters per second, making this one dx dt equals 5 meters per second. Now we're told to find the rate, which is how fast the distance between the boy and the balloon is increasing at t equals to 3, which is basically dr dt, this rate at this specific time. So what we do first of all is we find the distance between them at this point. Distance, of course, is given as v times t, v being dy over dt for the balloon, and then dx dt for the boy. Using this formula, we find that for the boy is 15 meters. The balloon is different, however, considering the fact that it's already 15 meters, so we add the 15 meters that it was in the initial position plus this. We sub those in, then we get a 21. As you can see, this forms two parts of a triangle. They're opposite on the hypotenuse. We have to find this point, the length of this, which I'm going to call r. R is basically the distance between the balloon and the boy at 3 seconds. We can use Pythagoras theorem to find this, giving us 25.81, which is an approximation. Using the same method, using the same formula, Pythagoras theorem, we can also derive in order to find our rate, dr over dt. We work that out and then just sub in at the end, where we get x times dx dt plus y over dy dt over r equals dr over dt. The 2's disappear because they are common and therefore they can be divided throughout. You find that the rate is 4.35 meters per second.